Hi everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we're going to be talking about limiting reactants. So first of all, what actually is a limiting reactant? Well, if we give you the example here, we've got A plus B, both of them are reactants. They chemically combine together to form a new product, AB. If we quantify this and put some numbers to it, let's say we had 10 grams, for example, of A and 5 grams of B, we can see that we make a new product. However, there is only a small amount of B compared to A, and that means we can only actually react so much of the reactants together to make the product. So the limiting reactant in this case is going to be B, because there's less of it. And if we go off the idea that one amount of A reacts with one amount of B, you can see that there's an actual excess of the A. There's 5 amounts left. There's a double the amount of A than there is B, and that's what we mean by limiting reactants. There's only so much product that can form because there's actually a reduced amount of that reactant there. Now, it's really important that we understand this because this comes across in chemistry in other places as well. So you may remember the required practical when you need to make copper sulfate crystals. And this is when you react copper oxide in excess with sulfuric acid. And the reason we add it in excess is because we want to make sure that all the sulfuric acid has been used up so that we create as much copper sulfate crystals as possible. So this idea of excess, that means there's lots and lots and lots of it compared to the other reactant. And limiting just means that there's less of it. So that's just a bit of vocabulary to clear up for you. Now, as you've probably gathered from this topic, there is a lot of maths involved in quantitative chemistry, and there's no exception here with limiting reactants. However, I must say, if you type it, you must write it as well. This is going for any calculation in science. If you type something in your calculator, please write it down as well. So many times in lessons that I have in real life, students will type something in their calculator, they'll get the right answer, but they miss out marks because they don't actually write down the working out. And in GCSE, most of the cases, most exam boards, if you write the right answer, you'll get the marks. However, if you make one small mistake on your calculator and you get a different answer, they're not going to see the process that you went through. So be very careful whenever you, especially with these types of calculations, they're multi-step calculations. There's lots of equations involved, and it's a good idea to definitely write down what you're doing, but have it in a logical flow as well. So I'll give you an example of the types of questions you could get asked about in this particular part of the topic. So if you have a look here, we've got a question. It says calculating masses. So one of the key ways they could ask you in the exam about limiting reactants, they will give you a question like this. So calculate the mass of aluminium chloride, which forms when 3.4 grams of aluminium are reacted with an excess of hydrochloric acid. So we have the reaction here in a formula view. So you've got 2 lots of aluminium, which reacts with 6 lots of hydrochloric acid, and they produce 2 lots of aluminium chloride and 3 lots of hydrogen gas. Now, you're given some information about this. Not only you're given the coefficients, so how much of each is created, so that will help us with ratios. If you are unsure what I mean by that, have a look at my previous video that I did where I talked a bit about ratios. I would recommend watching that as well. I'll link it for you. But you're also going to have to work out the mass. And as we know, we have this mass is equal to moles times the MR formula that we've, or equation, I should say, that we've talked about before. So any videos that we've covered, I will link at the end of this video too for you. So how do we actually work this out? Well, what you're going to want to do, first of all, is you're going to want to convert the mass that we have into moles for both reactants. Now, what I recommend you do is this question has a lot of information in it, and we want to make sure we know what it is we actually need to write down. So the first thing, we have a number in the question. It says 3.4 grams of aluminium. Write that underneath the aluminium. And we know that it's reacting with hydrochloric acid in excess. Now, we don't need to know how much hydrochloric acid there is, but we know that it's got to be a lot more than 3.4 grams because it's in excess of it. Okay, and it's asking us to calculate the mass of aluminium chloride. Well, that's what we want to work out, so we put question mark. Now, they've not actually mentioned hydrogen, so we can put a cross next to it. We don't need to worry about hydrogen at all in this question. So the first step you want to do is work out what we can. We know we can work out the number of moles because we have the number of grams for aluminium. So let's do that first of all. We work out the MR by looking at the periodic table. We look at the mass number, the biggest number, and we can see that it's 27. And we know that 3.4 grams of aluminium is what we have in the question. So when we do moles is equal to mass divided by MR, we get an answer of 0.126 moles. And that's the first step to this question. So as you can see in the formula at the top, we've got 2 lots of aluminium, which is used to make 2 lots of aluminium chloride. And because those are the bits of information we're looking at, they are the coefficients that we want to look at as well. So the ratio between the aluminium to aluminium chloride is a 2-to-2 relationship. And we've basically got that information from the symbol equation above. However, we can simplify this down to a 1-to-1 relationship by just dividing by 2. And therefore, we know that the number of moles of aluminium chloride produced would be the same number of moles as the amount of aluminium that we've just calculated. So the answer in this case would be 0.126 moles of aluminium chloride. And then, of course, lastly, we need to answer the question. So we've worked out these steps. We've got the number of moles of aluminium chloride, but the question itself is actually asking us, what is the mass of aluminium chloride that is produced from the aluminium and the hydrochloric acid in excess? So what we need to do is rearrange the equation above. So we have mass as the subject, and that will equal mass as the subject equals moles times the MR. Now we know the number of moles of aluminium chloride because we've just calculated it using the ratio. So that'll be 0.126 times by the MR. And again, like I said, we want to use the periodic table to do this, and you'll be given a periodic table in the exam. So I've done this as a quick way of doing it for you. You can see that aluminium we know is 27. We know that chlorine, there are 3 lots of them here. So it's going to be 35.5 times 3. And if we work this out, we can actually see that this comes out as an answer of 133.5 grams. Now, something a few students have asked me in the past is whenever they use periodic tables, maybe on Google, different versions of the periodic table, there are slight differences in the mass number. Sometimes there's more decimal points and things like this. What I recommend you do is use the periodic table for your specific exam board. If you just type in periodic table AQA or periodic table OCR, they will have a specific periodic table that you will have in your exam. Get used to noticing the numbers that they use. For the most part, they're quite similar, so it shouldn't make a big difference. But if you are a bit worried about it, go with that. I also recommend in these types of questions, you do not round until the very end, only round at the end. And that way you will get the best answer possible that hasn't had any slight differences. You do get a bit of allowances in the exam. There is a bit of discrepancy if you do round a bit before, but do round at the end. That way you can prevent that from happening. So let's go with another example. I think it's good to practice some of these. So the question is, calculate the mass of sodium oxide, which is produced when 145 grams of sodium combusts. So you can see that we've got 4 lots of sodium reacting with 1 lot of oxygen, and this creates 2 lots of sodium oxide. Now, what I've done as well is I have written underneath those symbols what actually we know and what we want to know. So you can see that we have 145 grams of sodium. Okay, we know that it combusts in oxygen, or it is ignited in oxygen. It essentially reacts with oxygen. And then we have a certain amount of sodium oxide, but we're trying to calculate that mass. So that's why there's a question mark there. The next thing we want to do, like I said, with any question like this, you want to work out what you can. So we know we can work out the number of moles of sodium because we've only been given the mass of it. We can work out the MR using the periodic table. So that's the first step, work out the number of moles. So if we use the equation, moles is equal to mass over MR, we know that there's 145 grams divided by 23. And remember not to use the coefficients in this case. The number 4 in front of the sodium, we don't need to use until we look at the ratios. Okay, so just be aware. I have an answer here of 6.30 mole. Remember the units of moles is mole, which is I think quite funny because it's just one E removed, but here we are. So there's the answer there. Okay, so the next step you want to do, like I said, is work out the ratios. How are these 2 bits of information related to one another? So we're comparing the amount of sodium that can be used to make the amount of sodium oxide. So we have a 4-to-2 relationship. That essentially is from the reaction above. I've just got that information from there. So if we have a 4-to-2 relationship, we can actually again, simplify this down to a 2-to-1 relationship, which means if we have 2 lots of sodium, we can only get 1 lot of sodium oxide, which means that we have to divide it by 2. So our answer of 6.30 moles, we now divide by 2 because we can only make half the amount of the sodium oxide. And therefore, when we do that, 6.30 divided by 2, we get an answer of 3.15 moles of sodium oxide. Okay, so now we have that answer, we can work out the mass of sodium oxide, which is essentially what we're trying to do in this question. So we work out this by doing mass is equal to moles times the MR. We know that the number of moles is 3.15. We've just calculated that, and we're going to times it by the relative formula mass, or the MR of sodium oxide. So there's 2 lots of sodium, okay, and there's 1 lot of oxygen. So 23 plus 23, that's the 2 lots of sodium, plus the 16 for the oxygen. We get an answer totaling 195.3 grams for the mass of sodium oxide. Like I said, if you would like me to do a short showing you how to work out the relative formula mass with the periodic table, I'm more than happy to do that, because I know it's a bit more tricky to actually explain this on the internet as it would be in a classroom setting. I could just point to where I'm talking about. Do let me know. I'm more than happy to create that. But hopefully from those examples that you've seen, you're starting to feel a bit more confident about this topic as well. Speaking of, here is a question for you. Have a go at it. It says, calculate the mass of water, which is H2O, which forms when 35 grams of methane, or CH4, reacts with excess oxygen during a combustion reaction. Like I said, go back, check the steps that we've talked about already. Comment below your answer. Show you're working out. I'd love to hear from you. Thank you so much in advance for doing that. And I will leave the answer, the solution, in the description box down below. Okay, so that's it from me. Thank you very much for your time. If you did enjoy the video, feel free to give it a like. I've been the GCSE science teacher and you have been curious. I have also other videos over on this side of the screen, which you can click on if you're interested. And I also have other social medias on this side, TikTok and Instagram, which you can explore at your own leisure as well. Until next time, I hope you have a fantastic day and I'll see you soon. Take care. Bye.